Chapter 13. Okay. We did few of the worked examples and few questions. 13.1 we did maximum. 13.2 position vectors, worked examples, and yeah. Did you get time to solve any of these?
As practice, no, not a lot.
If you didn't get time, we can do it together.
Okay.
Okay. Exercise 13.2. Find AB in form AI plus BJ for each of the following. So, question 1, A part. A is given 4, 7. B is given 3, 4. And when we need to find AB, AB is OB minus OA. Second letter minus first letter. So OB is 3, 4 and OA is 4, 7. 3 minus 4 is minus 1. 4 minus 7 is minus 3. And in this form, we can write that AB is equal to minus I minus 3J. Similarly, let's try this F part where A is 5 minus 6, where B is minus 1 minus 7. So AB is equals to OB minus OA. Minus 1 minus 7 minus 5 minus 6. So that's minus 6 minus 1. AB in IJ form is minus 6I minus J. Any doubts?
No.
Look at question number 2. O is the origin, P is 1, 5, PQ is given 3, 5. Find OQ. First one we need to find OQ. So PQ is given, PQ is OQ minus OP. We can either substitute right away or rearrange first. PQ plus OP is equal to OQ. So finally OQ would be PQ, that's already given 3, 5. OP is the position from origin is 1, 5. 3 plus 1 is 4, 5 plus 5 is 10. There's no restriction in what order they need, so we can write it as column vector or IJ form. That won't be an issue. B part. O is the origin, E is the point, and EF is this. Find the position of vector of F. Try this.
I'm getting negative 5 over 11.
What are you getting?
Negative 5,
Yep,
11.
that's right. Negative 5, 11 is correct. Okay. I'm skipping C part, that's same type. Question number 3 says the vector OA has magnitude 25 units and is parallel to this. Vector OB has magnitude 26 units and is parallel to this. Find OA. Magnitude of OA is 25 but is parallel to minus 3, 4. So first of all, I know that this vector minus 3i plus 4j, its magnitude is going to be 3 square plus 4 square whole square root, that's 5. So unit vector in this direction will be 1 by 5 of minus 3i plus 4j. And we already know that OA is 25 units. When this is 1 unit, so OA is equals to 25 into 1 by 5 into minus 3i plus 4j. 5 1 times and 5 5 times. Remaining 5 multiplies inside is minus 15i plus 4 5 times is 20j. Try B part. Find magnitude of 12 5, then divide by the magnitude, and then multiply it with 26.
B part, right?
Yes.
Twenty-four I plus 10j.
This is 3B. 24i plus 10j. That's correct. And A is also correct. Okay. Relative to the origin, the position vector of A is given, the position vector of B is given, the point C lies on AB such that AC is equals to this much. So first part is we need to find AB. When we need to find AB, A is given, B is given. Question 4, AB is OB minus OA, where B is 9 5 minus A is minus 7 minus 7. 9 minus 7 minus 7 is 16 and 12. So this is 16i plus 12j. Find the unit vector in direction AB. Unit vector. So vector divided by magnitude. 16 square plus 12 square whole square root. So this is the unit vector in direction of AB. 16 square plus 12 square, I'm getting exact 20. So 1 by 20 of 16i plus 12j. We can keep it as it is or multiply that inside. I'm just taking out common. 16 and 12 are both divisible by 4. This is 4i plus 3j. So we can write 1 by 5 of 4i plus 3j, or 4 by 5 plus 3 by 5, any form. Then it says find the position vector of C. So using the given information, AC is equals to 3 times CB. So I'm going to split that up. OC minus OA. On the other side, 3 stays there. OB minus OC. Now we rearrange and make OC the subject. OC minus OA equals 3 times OB minus 3 times OC. This comes on left hand side, makes it 4 OC is equals to 3 times OB plus OA. So 4 times OC, 3 times OB. So OB is 9, 5. OA is minus 7. So OC is equals to 1 by 4 of 3 9 times. I'm using calculator. 3 into 9 minus 7 is 20. 3 into 5 minus 7 is 8. 20 by 4 is 5. 8 by 4 is 2. 5i 2j. Question number 4. C part. 5i 2j. 1 by 5. 4i 3j. And 16 12. Any confusion?
No.
Okay. More or less now the questions are actually repeating themselves, because we either have position vector, or we have unit vector, or we have a new vector which is this much times the unit vector. Okay, just try question number 10, and then we will move on to next subtopic.
So AB is equal to 6I minus 8J. And then position vector of C is 10.5I.
Both are correct. Very good. Okay, let's see what do we have in our next subtopic. Vector geometry. That's again simple. Addition, subtraction, and handling of scalar multiple along with the diagram. OA is equals to A. If you just look at the diagram and the information given on left side, we can also label it or just use it from the text. OA, this full length, OA, this vector is equal to A. OB is B. And BX is 3 by 5 of BA. So if I just write 3 and 2, 3 by 5 of BA. And OY is 3 by 4 of OA. So this is 3 and this is 1. So find in terms of A and B. BA. Now when we are looking at this, BA. Would you agree? BO plus OA.
Yes.
BA is BO plus OA. And we already know that OB is B, so BO must be negative B. And OA is A. So BA is A minus B. We can rearrange or we can leave as it is. So BA is A minus B. Then it says BX. So BX. Using the given information right there, BX is 3 by 5 of BA. So we just copy that answer from the previous part. So 3 by 5 of A minus B. OX. So OX is going to be OB plus BX. OX is OB plus BX. So OB is B, where BX. While I copy that down, I'm simplifying it at the same time. This is 3 by 5 of A minus 3 by 5 of B. So we collect the like terms. A is alone 3 by 5 of A and 1 minus 3 by 5. 1 minus 3 by 5 is 2 by 5. So that's 2 by 5 of B. Either we leave it like this or we take 1 by 5 is common. 3A plus 2B. OX is done. And let's just tally as well. OX is 3 by 5 and 2 by 5. Yeah. Now it says BY. We're looking at B. We're looking at Y. It is BO plus OY. BY is BO plus OY. So BO is already minus B, where OY, it is given in question that OY is 3 by 4 of OA. So 3 by 4 of OA, where OA is A. So we just rearrange it, 3A by 4 minus B, and that's done. Similarly, we just keep on reading and do the right substitution, then the simplification, and it's done. B part says, given that OP is equals to lambda times OX, find OP in this terms. So basically, OP is equals to lambda times OX. We can do nothing but replace OX with the vector we found. So A third part was OX. So this is lambda into 3 by 5a plus 2 by 5b. Either leave it like this or 3 lambda by 5a plus 2 lambda by 5b. C part says, given that bp is equals to mu by, bp is equals to mu times by. Again, we copy the question. bp is mu times by, and b p. Did we find anything related to that? Find OP. So OP is going to be OB plus BP. OP is OB plus BP.
Sorry, could I quickly get some water?
Yeah, sure. Waiting.
Okay, thank you.
Okay. So C part was asking for OP. We're looking at diagram. OP is OB plus BP. So OB, OB is B, and BP is mu times BY, and BY is in the A4 part, and that was 3 by 4A minus B. So B plus 3 mu over 4A minus mu B, and we can collect the like terms. 3 by 4 mu A, and when we take out B as common, this will give me 1 minus mu into B. Hmm. Find the value of lambda and the value of mu. So if you see, we've done OP in B part and OP in C part. We can equate those two. OP was this, and let me just use the full space. 3 lambda by 5A, 2 lambda by 5B. This is OP is equal to OP. On the other side, OP is 3 by 4 mu A plus 1 minus mu B. So on left hand side, coefficient of A is 3 by 5 lambda. On right hand side, coefficient of A is 3 by 4 mu. On left hand side, coefficient of vector B is 2 lambda by 5. On right hand side, coefficient of B is 1 minus mu. So we can solve these two equations to find lambda and mu. 3 cancels out, go cross multiply, taking lambda as making lambda the subject. And we can substitute this in the other equation. So 2 into lambda is 5 by 4 mu over 5 is equals to 1 minus mu. So 2 into 5 divided by 4 is 5 by 2, divided by 5 is 1 by 2. This is 1 by 2 mu is equals to 1 minus mu. This comes on this side, it makes it 3 by 2 mu equals 1. So mu is equals to 2 by 3. When mu is 2 by 3, we can find lambda 5 by 4 into 2 by 3 is 5 by 6. 5 by 6 and 2 by 3. 5 by 6 and 2 by 3. Try this worked example. More or less, again, the things are same. We are just looking at the diagram for the path and the direction. Which vectors must be added, which must be subtracted.
So AI part would be 4b minus 3a, then II would be negative 2b plus, no, 3a minus 2b.
Yeah, that's
And
right. In
then,
any order, that's right.
yeah. And then part B, yeah, part B would be, that's, and no. Okay, so 4b plus lambda 12 over a over 7 minus 4b, and that was in brackets.
That's right.
And then part C would be, well, let me see.
B had two parts, BX and MX. BX and MX.
Yeah, and then there's a C part.
Okay.
If mx and a are collinear.
MX when they are collinear. Yeah. So what we can do is, in this case, if M, X, and A are collinear means they lie on one line. So we can write, we already had MX and we already had MA. So we can write MA is equals to K times MX. I just hope K is not used earlier. Or the other way around. We can also write MX is equals to K times MA. Anyway, but it is understood if I'm writing it like this because I can see on the diagram. So K must be more than 1 because MX is actually smaller in length. And if we choose the second order, K would be less than 1. Nonetheless, answers would be same. So if they are collinear, they lie on one line. So they are multiple of each other. So now we can just substitute MA, which is already done, MX, which is already done, and then compare left hand side coefficient of A with right hand side coefficient of A and B. In that order, we'll get equations and solve for the unknown. See, MX equals K times MA. So K is just there and we just substitute and then compare. See, A had 12 lambda over 7. On right hand side, A had 3K. So we just compare. This is now K and lambda, two unknowns. Another
Okay.
equation, coefficient of B on left side and coefficient of B on right side. Two equations, we solve these two equations simultaneously and get the values. And now practice exercise of the same concepts. Let's see question 1. OA is A. This is A. I sometimes label on diagram so I don't have to go back to text again and again. OB is B. R is the midpoint of OA. If that's the midpoint, I'll mark it like this for me, or I'll write 1:1. R is the midpoint of OA and OP is 3 times OB. OP is 3 times OB. That would mean this is B, this is 2B, and this complete is definitely 3B. AQ equals lambda times AB, and RQ is mu times RP. Find OQ in terms of this. Okay, now I'm looking at the diagram. This is exercise 13.3, question 1, A part. It says find OQ. When I'm looking at diagram, I'm taking this path OA plus AQ. So OA is clearly A and AQ. That's given in question that it's lambda AB. That's lambda AB. Now you can figure out that AB is actually BO plus OA. That's BO plus OA. Now you can replace them with vectors. BO is minus B, OA is plus A. So A plus lambda A minus lambda B. 1 plus lambda times A minus lambda B. A part done. Then it says OQ in terms of mu A and B. And where was this mu? Mu is in RP. So I'll have to take this path to involve mu. So OQ is now OR plus RQ. OQ is OR plus RQ. Before we replace them with vectors, I'm simplifying a little bit more, where RQ is going to be mu times RP, and we can further simplify this RP. RP is RO plus OP. RO plus OP. And this is time to replace the vectors. OR is A by 2 because that was midpoint of OA plus mu times RO minus A by 2 plus 3B. So this is A by 2 minus mu by 2 A plus 3 mu times B. Taking out A common is 1 by 2 minus mu by 2 into A plus 3 mu B. Find the value of lambda and mu. So we already have OQ and we can now equate them. This is OQ, this is OQ. So I'm just directly picking up coefficient of A, that is 1 plus lambda. On the other side, coefficient of A is 1 by 2 minus mu by 2. And then coefficient of B is negative lambda. On the other side, that's 3 mu. So lambda is minus 3 mu. I'll replace this. Substitute this lambda here. So 1 minus 3 mu is equals to 1 by 2 minus mu by 2. Rearranging numbers on one side, 1 minus 1 by 2 is equals to 3 mu minus 1 by 2 mu. That's 1 by 2 already. 3 minus half is 5 by 2. 2 cancels out. Mu is 1 by 5. When mu is 1 by 5, we can find out lambda, that is minus 3 into 1 by 5. It's minus 3 by 5. So mu is 1 by 5 and minus 3 by 5. This is question 113.3. 13.3 question 1. Lambda 3 by 5, mu 1 by 5. But I'm getting a negative sign. We quickly check that. Mm. Mhm, mhm. Mu is 1 by 5, lambda is 3 by 5. Why are we getting that negative sign? I'm getting that negative sign. Let me just quickly check them while substituting them back. If this is 1 by 5, lambda is, I'm getting minus 3 by 5. So if I just plug it back, 1 minus 3 by 5, I'm getting 2 by 5 of A, and minus minus is plus 3 by 5 of B. And for this, where mu is 1 by 5, so 1 by 5 divided by 2.5 minus answer is 2 by 5 of A, and 3 into mu is 1 by 5, so 3 by 5 of B. We're getting exact same answer. There's a typo in the marking. So these are both correct. I'll just quickly see what is after this constant velocity problems. Okay. Splitting velocity into components. Okay. One more subtopic, then this will be done. Okay. So skipping question two, try number three. That's of similar nature. All these questions would have same nature. Let's try that once. Number three.
For A part, it's 3 over 5A plus 6 over 5B. And then for B part, it's 3 over 5A. Right.
Um, 13.3, question 3. OX in terms
Oh
of
no, no. It's lambda A plus 2 lambda B. And
lambda,
then
lambda
B
p.
would be, yeah. Um, I don't know how to pronounce that one, but
That's mu. Just let me know if C part is same. Then definitely A and B would be correct.
okay, C part here.
Lambda 3 by 5. Are you getting this?
Yeah, both are the same. Yep.
Both are same. That is correct. Okay. Now let's just see if any question seems a bit different, which actually is not. Okay. Let's look at this next subtopic. Just a second. I'll start. Okay, constant velocity problems. If an object moves with the constant velocity, let's say velocity is 4i minus 2j, that would mean it is taking 4 steps to right and 2 steps downwards, and this is the resultant direction, this much meters per second. The velocity can be represented on the diagram as shown. Velocity is a quantity that has both magnitude and direction. We can see the magnitude and direction is represented by 4i and minus 2j, and magnitude is exactly the same, x square plus y square whole square root. And we should already know this formula: distance is speed into time, or speed is distance over time. Velocity is displacement over time, splitting velocity into its components. So if we have that already, remember trigonometry, the horizontal component and vertical component, we can use this angle to split them up into horizontal and vertical components.
Yeah.
So using cos and sine in this case, that's 45. That is why both are same, because it is isosceles triangle. Won't be same if angle is not same every time. So we're just splitting this up. This is 4 square root 2. So this would be 4 square root 2 cos 45. This will be 4 square root 2 sine 45. And resulting answers in this case is 4 and 4. When we have 60, this right in front of that is perpendicular component with respect to this angle. So this is going to be 20 sine 60. And this is going to be 20 cos of 60. So 20 sine 60 is giving me 10 square root 3, and 20 cos 60 is giving me 10. So we have components of velocity. An object travels at a constant velocity from point A to point B. AB is given 32 in x direction and minus 24 in y direction. And the time taken is 4 seconds. Find the velocity. And the velocity is displacement per unit time, which is already given per unit time. And time is given 4 seconds. So it is traveling definitely. It was 32. So dividing in 4 sections, that would be 8. Then this was 24. Dividing in 4 sections, this would be 6. So 8 and 6. 8i minus 6j. Whereas speed is the scalar quantity. So total magnitude, that is already per second. Either we solve from these two, like 32 square plus 24 square whole square root, and then divide by 4, or just use this and find the magnitude, and we are getting 10 6. I'm also checking with 32 square plus 24 square whole square root. I'm getting 40. So that's 40 by 4, and we end up with the same answer. 10 meters per second is the speed, and 8 and 6j is the vector quantity, that is the velocity. Consider a boat sailing with velocity 3 minus 2. At 1200 hours, the boat is at A with position vector this, kilometers to relative to the origin. The diagram shows position of the boat at 1200, 1, 2, 3, 4, 5 p.m. It is given the position at 1 p.m. So already at A, this was 3:13. It is already given. So at 1 p.m., that is 1 hour later, and the speed is given 3 minus 2 kilometers per hour. So every hour, x moves 3 units to right and y moves 2 units down. So this was 3, 13 already. So 3 minus 2. 3 units to right will be 3 plus 3 is 6. 13 minus 2 is 11. So this is 6, 11. See, and then another fall of 3 minus 2, x 3 units to right and minus 2 is 9. So 9, 9, and so on. So we would actually know that if the time is given, we can say the starting point stays there plus time into 3 minus 2, because this is kilometer per hour. So if it is for 2 hours, we'll multiply with 2 and then add. If it is for 7 hours, we'll multiply with 7 and then add. So basically the resultant is initial point plus time into speed is giving me the new position, the new distance. If an object has initial position A and it moves with a constant velocity V, generalized form, so R is equals to initial position plus time into velocity, where velocity incorporates direction already. Work the example. Particle A starts moving at time t is equals to 0 from the point with position vector 52i plus j with a speed of 15 meters per second in the direction. Be careful with the vector is this and speed is this. Speed is actually the magnitude in this direction. Direction is this. Okay. Find the velocity VA of A. So we know the direction, we know the magnitude. 3, 4. If I just look at 3, 4, 3, 4 is 3 square plus 4 square whole square root is giving me 5. If this is 5, this is 15. That actually means it is 3 times more. 15 divided by 5 is 3 times more. So if I multiply this with 3, it is giving me minus 9i plus 4 3 is a 12j. This is the velocity. And let me just confirm minus 9 and 12. Yes. Are you getting it?
Yeah, I think so.
Okay. B part says find the position of RA. Okay, RA. So RA is basically fixed point plus time into velocity. So fixed point. Particle A starts moving at time t0 from the position 52 I and j. So this is 52 and 1 plus time. And when do we need to find the position R after t seconds? Particle B starts moving at time t is equal to 0 from point with position vector this. We are finding position of A after t seconds. Okay, so general form, this is 52i fixed point plus time into velocity. We just found the velocity, that's minus 9i and 12j. Yep. And in form of ij, I just had that habit 52i plus j plus time into minus 9i plus 12j. Now, particle B starts moving at time t is equal to 0 from the point with position vector this. This is the fixed point, velocity is given. Fixed point is given, velocity is given. Show that A and B collide and find the value of t when they collide. So equation for RA is already there, which is 52i plus j plus time into minus 9i plus 12j. And then direction distance for B is fixed point minus 11i minus 8j plus time into this was 12. 12i plus 15j. So that A and B collide and find the value of time when they collide at the position vector and the position vector, time and position vector. So if they're colliding, RA must be equal to RB at the point where they meet. So the position must be same. So 52i plus j minus 90i plus 12tj is equal to minus 11i minus 8j plus 12ti plus 15tj. So now we're dealing with all i's and all j's on left side and right side. So on left side, the I is 52 minus 90. This is I. And j's are 1 plus 12t. This is j. On right hand side, these are i's minus 11 plus 12t. This is I. And these are j's minus 8 plus 15t. That's j. So I is equals to I. 52 minus 90 is equals to minus 11 plus 12t. Rearranging, 52 plus 11 is 63 and 12 plus 9 is 21. 63 divided by 21 is 3. So t is equal to 3. We can double check with j's as well. 1 plus 12t is equals to minus 8 plus 15t. 8 comes on this side, that's 9. 15 minus 12, that's 3. And yes. So time is 3. What were the two requirements? Show that A and B collide and find the value of t. T is 3. And the position vector of the point of collision, position vector. So we know t, we can substitute t in any of the equations. This is already written where t is 3. So let me solve this, use this, and that's 52 I. And when t is equal to 3, 3 into 9 is minus 27 I plus j, and 3 12 time is 36 j. So this is going to be 52 minus 27 is 25 I and 37 j. And I just hope after all this we get same answer, 25 and 37. And that's correct, 25 and 37, and time is 3. This would need a little practice or else things would mix up. And this is probably the last subtopic of this chapter. Yes, past paper questions, and then we'll be left with our one chapter, which is permutation and combination. Last example done. Okay.
And then afterwards, we would have past paper practice.
Yeah, then the syllabus is complete, and we'll go for past paper practice.
Oh, could we do topicals instead? Like for
Yeah, we can do both.
okay.
We can do both. Then, like, we won't have to worry about the syllabus completion. So whatever is best, we can keep changing uh, as required.
Okay.
Okay. Try question number 1.
I'm getting for A part 3.5I plus 9J meters per second. For B, I'm getting 30I minus 36J. And then for C, I'm getting 12.5 hours.
Very good. Excellent. Now all these are similar. Velocity is the vector part, speed is the magnitude part, distance is from speed into time, and velocity and displacement with time, speed and distance with time. In our next class, we'll go to our last chapter and then topicals or papers as required.
Okay.
Anything else you would like to know?
No questions.
Okay. This would need some practice. Okay,
Yeah.
give it a try, and where we have these past paper type questions. These are exactly past papers or topical worksheets. So do try them as well, or straight away jump to this for practice. Okay.
Okay.